Good evening, Priya. Welcome. Very good evening. Yes. All right. So, see, we are after a very long time, after like approximately 1 month, we are going to restart our Claydon Organic Chemistry series because I was more indulged in doing the practice sessions for the GATE examination. So, अब जो है, we are going to continue our organic chemistry series. And see, guys, most of the basic part is already done. Right, that is since we have like reached chapter 31, इससे पहले के जो भी basic वाली थी वो लगभग हमने complete कर लिया है. Now we are going to move onwards to the higher level topics, and in this particular session we are talking about chapter 31, which is very important because questions are not asked directly from over here, but this is a very eye opening kind of a session. ठीक है, क्योंकि यहाँ से ही शुरू होता है advanced tricks based on how the cyclization is going to take place, what are the factors which are going to affect the cyclization. फिर कई सारे cyclic molecules हैं, उनमें protons different हो जाते हैं. You must have already heard about diastereotopic protons, enantiotopic protons, all those things. ठीक है, so that is what we are going to discuss in today's session. Baldwin's rules, Thorpe in gold effect, एंड कपलिंग ऑफ प्रोटॉन्स. तो ये सारी चीजें चैप्टर 31 में ये तीन चीजें बहुत ज्यादा इंपॉर्टेंट है. सो दिस इज व्हाट वी आर गोइंग टू डिस्कस. Yes, very, very good evening, Navneet and everyone, guys. It's very nice to see all of you once again. So let's start our discussion. Now, as you know, guys, before moving onwards, there has been a lot of request about जो already CSIR net का content पढ़ चुके हैं मेरे से, maybe on my app or let's say on my previous platform. For all those students who kind of already have covered the syllabus, but due to some reason they did not get enough score, let's say their score is around 70 to 90. इसके बीच में अगर आपका स्कोर लटक गया है, आगे ही नहीं बढ़ रहा है, so for those students this is a very much requested batch which I am launching over here, repeaters batch, and this only focuses on the question practice. तो जितने भी टॉपिक्स है ऑर्गेनिक इनऑर्गेनिक केमिस्ट्री के, we are going to have question practice. कहाँ का question? CSIR NET, GATE PYQ, as well as important book questions. All of this combined, I am providing all of you, and this particular course is for all those students जिनको भी यहाँ पे जो जिनका स्कोर है, okay, and this is going to like accelerate directly from here to let's say more than 110. ये बहुत ही proven सी चीज है. मैं बहुत ज्यादा बोस्ट नहीं कर रही हूँ गाइस, बट ओनली कंडक्टिंग ओनली बैटल ऑफ क्वेश्चन मेक्स अ लॉट ऑफ डिफरेंस. व्हाट इज अ बैटल ऑफ क्वेश्चन सीरीज? 9 to 10 सेशंस ऑफ ऑल कंप्लीट क्वेश्चन प्रैक्टिस. सिर्फ उतना सा करने से स्टूडेंट्स के ऊपर इतना ज्यादा फर्क पड़ जाता है. सो दिस इज अ कंप्लीट प्रैक्टिस बैच. So I'm 100% sure that this is going to elevate your score from 70 to 90 से लेकर directly you're going to crack JRF. इतना तो मेरा confidence है ही. Also, इसमें और क्या मिल रहा है आपको? I will be also conducting topic wise test as well as complete mock test. तो जो mock test series है वो भी आपको इसमें मिल जाएगी. Everything you are going to get in the same course, and the cost is around 2500. The same as the Raftaar Batch, which was also for the last crash course के type का ही था. तो ये भी एक crash course है, लेकिन मैंने अभी क्यों start कर दिया है? Because a lot of students were asking me कि मैम we don't want to study the whole syllabus, we only want to practice. So for those students this particular course is there. ठीक है, चलो guys start करते हैं. Let's start our discussion. Very beautiful chapter this is, and the chapter which is coming after this, chapter number 32, is again very awesome. जिनको stereochemistry से प्यार है उनको बहुत अच्छा लगेगा ये chapter. ठीक है, चलो शुरू करते हैं. So the name of the chapter is Saturated Heterocycles and Stereoelectronics. And look at this, what is it talking about? जो first most striking चीज मुझे लगी इस chapter में, which and this concept has already been asked in your GATE examination once. Let's look at this. So it is the anomeric effect. Everyone has heard about the anomeric effect, yes or no? Yes. Good evening. अतुल, मारुति, वेरी गुड इवनिंग ऑल ऑफ यू. तो देखो आपको पता है ऑलरेडी that we talk about the anomeric effect in the case of glucose, mostly carbohydrates के बारे में बात करते हैं when we talk about the anomeric effect, right? So we usually say that if there is an electron withdrawing group like a chloride, like let's say a methoxy, let's say a bromide, whatever it is, कोई भी एक electron withdrawing group होता है, तो it is more preferred on the axial position as compared to the equatorial position. Everyone knows this concept, yes or no? ये equatorial position है, यहाँ पे preferred नहीं होगा, more preferred on the axial position. Why? What is the reason? Can somebody tell me what is the reason that anomeric effect favors axial conformer? Anybody? क्यों होता है ऐसा? Why does the axial conformer, why is it more preferred as compared to the equatorial? हाँ, lone pair repulsion reason है एक. This is one reason, because chlorine or any other electron donate withdrawing group will have lone pairs to repel with the oxygen. That is one reason. But the main reason is N2 sigma star transition. That is, the oxygen lone pair is going to put the electron density into the कार्बन क्लोरीन बॉन्ड, और ये जो रीजन है नाइट ऑक्सीजन का लोन पेयर इनटू द सिग्मा स्टार ऑर्बिटल ऑफ कार्बन क्लोरीन बॉन्ड, this only happens when they are achieving a anti-periplanar geometry. So because of this anti-periplanar geometry, we say that anomeric effect is favored. ठीक है, चलो, now we move onwards, guys. तो ये जो anomeric effect है, we are looking at this example from the book directly, and this has been asked in your gate question. So look at this molecule. Look at this molecule. What is it? It is a carbonyl. And you know that when the carbonyl reacts with a diol, it gives you an acetal, isn't it? A simple carbonyl is going to react with a diol like this. तो ये आपको देगा सबसे पहले तो this kind of a acetal. So we are not directly starting to study the Baldwin's rule. There is a lot of stuff before that. So we will just start from the basic of the chapter. जो सबसे पहला concept था, that was anomeric effect. Okay, right? Yes, yes. So there is steric hindrance also. अब देखो, because you are forming an acetal in the reaction of carbonyl and the diol. Now there is same thing happening over here. There is a diol within the molecule. So one by one these alcoholic groups are going to attack, and after the reaction it is going to give you a acetal. तो ये इस तरीके का एक acetal बनेगा. इसको हम बोलते हैं spiroacetal or spiroketal, because both the sides are alkane, so that's why a spiroketal. Now in your question, in the gate question, it was asked, out of this spiroketal there are many conformations which are possible. Let's say 3 conformation लिखा है सबसे ज्यादा, तो which one is the most preferred conformation? Yes, have you ever gone through this question? ये देखो, ये रहा question gate में जो पूछा गया था. Direct, the question was asked, look at this, the acid catalyzed cyclization of 5-ketodecane 1,9-diol is given below. So इसमें acid catalyzed cyclization में बना spiroketal. Out of all of these, which is the most preferred conformation? Good evening, Bhavya, Ananthi, Mavani, everyone, welcome guys. Yes, very nice to see all of you. So the same question was asked in GATE, and this is directly asked from Claydon. That's why Claydon तो है ही हमारा ऑर्गेनिक का बाइबल है Claydon तो. ठीक है, तो ये जो बहुत सिंपल सा क्वेश्चन है, इसका आंसर ये है that with respect to the electron withdrawing group, the other group should be axial. ठीक है, मतलब कि अगर एक ऑक्सीजन रिंग में है, if one of the oxygen is present in the ring like this, then with respect to this oxygen, the other oxygen should also be present axial, somewhat like this. Okay, either over here or over here. So this is what you have to take care of. तो देखते हैं दोनों में. Let's see in both of these. First conformation. First conformation में ये साफ साफ दिख रहा है that one of the oxygen, this oxygen with respect to this one, this is equatorial, right? क्योंकि ये एकदम से एक्शियल नहीं है, लेकिन इसके रिस्पेक्ट में ये एक्शियल है. विथ रिस्पेक्ट टू दिस ऑक्सीजन, this one is axial. So one axial, one equatorial means only one anomeric effect is working over here. Okay. Now with respect to this oxygen, this is equatorial, and with respect to this oxygen, this is also equatorial. दो इक्वेटोरियल हो गए, मतलब जीरो एनोमेरिक इफेक्ट हो गया है यहाँ पे, नो स्टेबिलिटी. देन नेक्स्ट, with respect to this oxygen, this is also axial, and with respect to this oxygen, this is also axial. अगर आपको ऐसे समझ में नहीं आ रहा हो, थोड़ा सा रोटेट करके आप देख लेना अपने मोबाइल फोन को, आपको समझ में आ जाएगा that both of these are axial with respect to each other. Okay, which means two anomeric effect are working over here, and this is the most stable conformation out of all of these. Okay, that is also based on the anomeric effect. Okay, this one is preferred. क्यों prefer है? क्योंकि ये भी n2 sigma star transition कर सकता है और ये भी कर सकता है. So any conformation in which a lone pair is anti-periplanar to a low energy anti-bonding orbital, that is the sigma star, low energy मतलब vacant होना चाहिए और easily accessible होना चाहिए, that will be stabilized by a stereo electronic interaction. So that is all the chapter is about. Stereo electronic interaction in the saturated heterocycles, isn't it? कि मतलब कि जो सैचुरेटेड कंपाउंड है उसमें भी मैटर करता है that which conformation is going to be more stable or less stable, right? Very beautiful example directly asked in the examination. तो यहाँ पे हमारा आंसर होगा ऑप्शन नंबर ए. Look at this, this is also axial, this is also axial with respect to each other. So A is going to be the correct answer. So easy. आगे चलते हैं. Now, so look at this. uh, yes, let's say हम यहाँ से स्टार्ट करते हैं इसके ऊपर. All right, there you go. So this is a very simple guide to ring cyclization. अब हम स्टार्ट करते हैं cyclization के बारे में पढ़ना. So what do we understand about cyclization? Whenever this is, we are just kind of setting the ground for studying the Baldwin's rule. अभी Baldwin's rule नहीं पढ़ना है, अभी सिर्फ simple cyclization पढ़ना है. So tell me, how many of you got confused in the examination कि मैम कभी तो 5 membered ring ज़्यादा faster हो रही है 6 membered ring से, and sometimes the 3 membered ring is faster than the 5 membered ring also. Yes, तो ये जो cyclization वाला concept है, this confuses almost everyone, right? And whenever a question appears on cyclization, it becomes very risky to answer, isn't it? So that is why we have a rough guide for the rate of formation of saturated rings. अब मैं जहाँ rate की बात करती हूँ, is rate a kinetic factor or a thermodynamic factor? Yes guys, you tell me that when I'm saying a ring is going to be formed faster, which means कि ये तो kinetic factor है ना. It is a kinetic factor, isn't it? कि ऐसा जरूरी नहीं है that is the most stable ring, but it will still form faster. Why is that so? What are the reasons behind it? ये देखो, the fastest ring which is going to be formed is the 5 membered ring, much faster than the 6 membered ring. This is going to be much faster than 3, then 7, then 4 और 8 और 10 तो slowest है, क्योंकि बहुत बड़ा रिंग साइज हो जाता है. सो अप्रोच बिकम्स वेरी डिफिकल्ट. ओके, या काइनेटिक फैक्टर. अब देखो, रिंग फॉर्मेशन किस पे डिपेंड करता है? रिंग फॉर्मेशन डिपेंड्स ऑन अ लॉट ऑफ रीजन. फर्स्ट सी, a 3 member ring formation is fast, the product is definitely strained. तो देखो, 3 membered ring formation होना fast होता है. I know the product is strained, तो उसकी जो delta H है that is going to be very high, large, but this is offset by the reacting atom being as close as they can get in a freely rotating chain. तो जो 3 membered ring formation है वो fast होता है. The reason being proximity. Proximity is the reason. यस, एवरीवन गेट्स इट, प्रॉक्सिमिटी है इसीलिए फास्ट होता है. Four-member ring forms slowly because the product is still significantly strained, but the reactive atom are now not right next to each other to offset this. देखो, जहाँ 3 और 4 member की बात आती है, so 3 also has strain, 4 also has strain, but at least 3 has a greater proximity factor than 4. That's why 3 member ring will form faster than 4. Okay, तो strain तो दोनों में ही है, but proximity 3 की ज़्यादा है, that's why 3 forms faster. Alright? Yes. Moving onwards, a 5 member ring formation is often the fastest of all. Why? Because significantly less strain and the ends are still not too far apart. दोनों reason है कि एक तो strain भी कम है, there is a less strain as well as high proximity. High proximity as compared to द 6 and 7 and 8 member रिंग, मतलब कि जो 5 member रिंग है वहां पे दोनों फैक्टर बैलेंस होते हैं. ठीक है, स्ट्रेन इज लेस, proximity is high. In 3 and 4 the strain is also very high even though the proximity is high. Okay, so yeah, that's why for the 5 member ring both are balanced. अब आगे चलते हैं. 6 member ring formation experiences no strain at all, but neither does it have the advantage of ends being close. मतलब यहाँ proximity भी नहीं है. Proximity is also less, right? That is the reason. Now 7 member ring and beyond are more slowly because the entropy increases. Entropy increases because of the number of carbons they are increasing. तो इनकी proximity और भी कम हो जाएगी. That's the reason. So for let's say roughly ये हमारा एक guide है that this is how the ring formation is going to take place. All right. This makes sense to everyone. Shall we move onward? कि हमेशा काइनेटिक फैक्टर तो होते नहीं है मैम, ये तो समझ में आ गया. But it's not that we only depend on kinetic factor. There are sometimes thermodynamic control over the ring size. So you know that when the ring size is considered, we say a 6 member ring is formed more, not, I would not say faster, but when there is an equilibrium being set, तो 6 member रिंग ज्यादा क्वांटिटी में बनेगी एज कंपेयर टू 5 member रिंग. यस, ये भी हमने देखा है, राइट? कहाँ देखा है? वेयर हैव वी सीन दिस? वी हैव सीन दिस इन द रिंग क्लोजिंग ऑफ कार्बोहाइड्रेट्स. फॉर एग्जाम्पल ग्लूकोज, क्योंकि आपको पता है ग्लूकोज कैन एग्जिस्ट इन ग्लूकोपाइरानोज फॉर्म as well as glucose can exist in glucofuranose form. दोनों फॉर्म में एग्जिस्ट करता है ग्लूकोज, बट at room temperature the pyranose or the 6 membered ring is going to be present more as compared to the 5 membered ring. That also you know, yes or no? ये भी हमें पता है. तो फिर ये देखो एग्जाम्पल, ओपन चेन फॉर्म ऑफ ग्लूकोज वेयर वी आर स्टिल हैविंग द एल्डिहाइड फंक्शनल ग्रुप. फिर ये अल्कोहल यहाँ अटैक करता है तो ये बन गया 6 membered रिंग फॉर्म ऑफ ग्लूकोज. All right. Now, if this alcohol is going to attack over this carbonyl, you will get this 5 membered ring. Okay. And if this alcohol is going to attack over the carbonyl, you will get this 7 membered ring. पर ये दोनों ही नहीं बनती है at room temperature. Let's say very less, very less. Why is that so? रूम टेम्परेचर पे क्यों नहीं बन रहे हैं ये दोनों? Because of the thermodynamic control. So whenever there is a question based on cyclization, जब भी आपका CSR net में question आता है based on cyclization, maximum times you are going to follow this order because they are asking you the kinetic factor, isn't it? वो तो बोल रहे हैं ना rate of reaction किसका ज्यादा है, so they are asking you kinetic factor. Based on that you will answer from here. But for the carbohydrates or for any other molecule, जब वो ऐसे पूछे which is a more stable form, or let's say this molecule exists in which form, तब आप बोलोगे thermodynamic factor predominates. All right, so how many of you have seen that question कि जब ग्लूकोज रिएक्ट करता है एसीटोन से, when the glucose reacts with aldehyde, it is going to give you the protection of 1,3-diol directly. 1,3-diol को directly protect कर सकता है. But when it is happening with the acetone, it is going to break the ring, form the 5-membered ring, and then it is going to get the 1,2-diol like this. तो फिर वो जाता है फ्यूरानोज फॉर्म में. Everyone has seen this? Yes. Everyone has seen this example, this PYQ in the exam. मैंने बहुत बार करवाया है ये, in free classes also. Many a times we have done this. All right. So उसको 5-membered में क्यों जाना पड़ा? Because there was no other option. That's why it goes into the 5-membered ring, right? So whenever a question is asked on rate of cyclization, you will consider kinetic factor. And when a question is asked on the stability of the conformation, then go with the thermodynamic factor. Okay. Now we move onwards to one more factor that contributes to cyclization. ठीक है, ये क्या factor है? ये वैसे तो steric factor है which is the major product. ऐसे ask किया तो हाँ प्रदीप, yes, then it is the kinetic factor only. Yes, right. So this Thorpe in gold effect, this is nothing but a steric effect. But क्योंकि इसका नाम है, so we just call it with this effect, okay? So the effect is a way in which substituents on the ring increase the rate or equilibrium constant for ring forming reactions. ठीक है? Yes. All right. तो बेसिकली ये जो रिंग फॉर्मिंग रिएक्शन है, इस पे क्या इफेक्ट पड़ेगा? स्टेरिक हिंड्रेंस का और या सब्स्टिट्यूएंट्स का. चलो देखते हैं. फर्स्ट एग्जांपल, लुक ओवर हियर गाइस. व्हाट डू यू हैव? यू हैव ऑक्सीटेन रिंग फॉर्मेशन, ऑक्सीजन रिप्लेसिंग अ क्लोराइड. सिंपल. इसका जो रिलेटिव रेट ऑफ रिएक्शन है दैट इज 1. बट सिमिलरली इफ आई जस्ट टेक 2 methyl ग्रुप्स ऑन द एडजेसेंट कार्बन, जो ये कार्बन जिससे ऑक्सीजन कनेक्टेड है, इससे मैंने 2 मिथाइल ले लिए स्टेरिक हिंड्रेंस के लिए, that increases the rate of cyclization by 400 times. So increasing steric hindrance is actually increasing the cyclization. ये कैसे हो गया? Let's see more examples. That is, if I am having a simple amine replacing the bromide to give you a 5-membered ring. This is our pyrrolidine ring. Very good. If I increase the steric hindrance on the same carbon as nitrogen, or it increases, or let's say doubles, right? But if I am increasing the steric hindrance over adjacent carbon, तब ये हो गया है 160 times. It increases 160 times. So what is happening? Why the steric hindrance is let's say doing the reaction, making the reaction faster? इसका कोई particular reason है? बिल्कुल है. इसका reason है bond angle का. Okay, what happens is, as expected, when we just have 2 hydrogens over here like this, there are two acid groups like this. What happens? Proton तो small होता है, and the acids are big, so the bond angle is high, 110 for example. But when there are bulky methyls, it is going to like push the groups inside towards themselves. ये ऐसे push करेगा ना यहाँ पे. Steric hindrance increases, bond angle decreases, and proximity increases. Okay, so proximity increases मतलब कि दोनों जो ग्रुप है वो पास में आ जाते हैं, इसलिए फास्टर रिएक्शन होता है. तो जो स्टेरिक हिंड्रेंस इंक्रीज हो रहा है, दैट इज ब्रिंगिंग द टू ग्रुप्स टुगेदर. पास में आने की वजह से रिएक्शन फास्ट हो गया. Okay, let's look at another example number 3 over here. 2 acid groups, rate of reaction is 1 only. फिर यहाँ पे हमने increase कर दिया दोनों methyl, rate of reaction increases 14 times. 14 multiply कर दो, इतना increase हो गया. Now I have put 2 more methyls over here. All right, maximum steric hindrance. 24,000 times rate of reaction increases for the anhydride formation. How nice. So it's a very clear effect, Thorpe Ingold effect. That is, when you increase the substituents on the ring, the cyclization is going to increase. All right. Yes, restrict the rotation. Restricted rotation also you can say, and you can say that the major effect is because of the bond angle. ओके, रेस्ट्रिक्टेड रोटेशन भी हो सकता है, लेकिन वो इतना बड़ा फैक्टर नहीं है. बॉन्ड एंगल जो है, जो प्रॉक्सिमिटी इंक्रीज हो रही है, वो ज्यादा बड़ा फैक्टर है. ओके भाव्या, चलो, let's now move onwards. And guys, as you already know, for those who are looking for starting their preparation for the June 2024 examination, you can join my Catalyst detailed batch. All right, it is going to be having a validity of 2024 till June examination. और जो आपका repeaters batch है, उसका भी यही validity है, same validity. And for the students who want to prepare for the GATE as well as CSIR NET examination, they can join up this detailed batch, GATE detailed batch. All right, and you're going to get basically everything, test series and everything along with the study material. So इसकी validity है 2025 तक, February तक. Okay, and the repeaters batch which I had announced in the beginning, that is also going to be having a validity of June 2025. All right, so whichever you want to join, you can join up and take all the benefits. अच्छा, अब आते हैं Baldwin's rules के ऊपर. So most awaited topic, Baldwin's rule. आधे से ज़्यादा लोगों को समझ में ही नहीं आता what is Baldwin's rule. It is very simple. Okay, tell me, how many of you have studied radical cyclization? कितने लोगों ने पढ़ा है? Have you all studied radical cyclization from the TBTH and the AIBN combination? Tell me yes or no. Yes, have you all studied that? Yes, yes, right. So in that we saw that exotrig, exotrig, this is favored, and the endotrig is not favored. ये याद है सबको? Yes, ये सबको याद है? Okay, चलो फिर. Based on this knowledge, we will move onwards. Yes, yes, प्रदीप कोशिश करेंगे. देखो, जो चल रहा है उसको तो चलने दो पहले. Okay, चलो, चलो. Baldwin's rule. Now, what is a Baldwin's rule? Yes, the cyclization reactions can be classified by a simple system involving the ring being formed, जो ring बन रही है, whether the bond that breaks as the ring forms is inside, endo means inside, और outside means exo, the new ring. मतलब कि जो bond break हो रहा है वो ring के अंदर है या ring के बाहर है, endo या exo. Third, whether the electrophile is an sp या sp2 या sp3 atom. तो अगर sp होगा तो ये होगा dig या diagonal, sp2 होगा तो ये होगा trig trigonal, या sp3 होगा ये होगा tetrahedral, so tet. So these are the shortcuts that we are going to use. Okay, very simple. अब देखो classification based on this. First very simple classification is, if I am doing a cyclization to form a three-membered ring, तो उसको हम क्या बोलेंगे? The breaking of a CBr bond. Look over this example. The breaking of a CBr bond. This bond is opening outside. तो ये क्या है? Exo. कितना? 3 membered ring forms. Outside 3 exo. And since it is a sp3 carbon, it is tetrahedral. So 3 exo tet. Got it? 3 membered ring formation. भले ही ये हो, भले ही epoxide हो, bromonium ion हो, whatever it is, 3 exo tet. Got it? Second number. Yes, very easy. The ring being formed has 5 members, 5 member ring बन रही है, and we are breaking a carbonyl bond which is outside the new ring. The new ring is formed over here, so this is outside. The carbon being attacked is trigonal sp2. So this is 5-exo trig. Okay. Then we move onwards. The ring being formed has 6 members now. The breaking is of a C triple bond. C क्या है? Diagonal. So ये dig आएगा यहाँ पे. This triple bond opening is coming inside the ring. All right. तो ये endo बन रहा है यहाँ पे. In this example, it is forming endo. It's going inside. Got it? बाहर वाले कार्बन पे अटैक हुआ, ये अंदर चला गया. So this is 6 endo coming from diagonal. So it is going to be dig. This classification understood by everyone, yes or no? Give me a thumbs up or just a y. जल्दी से लिख दो, फिर आगे चलते हैं हम. Yes, I hope that this is very clear, very easy. Now we move onwards. तो अब आता है Baldwin's rule. All the exotet cyclizations are favored. Yes. What does that mean? जितने भी ऐसे cyclization है which are forming, which are having the leaving group outside the ring and the carbon is saturated, all such are favored. भले ही वो 3, 4, 5, 6 कुछ भी हो, all are favored. Okay. 3 membered, 4, 5, 6, 7 कितना भी हो, all of these are favored because it is all saturated. All saturated. Saturated सब favored है. ठीक है. Now all exotrig cyclizations are favored. So again, भले ही 3 membered, 4 membered, 5, 6, 7, even though it is coming from sp2, those cyclizations are also favored. लेकिन 5 and 6 endotet are disfavored. मतलब कि whenever it is having a saturated carbon और वो अगर 5 या 6 membered ring बनाने की कोशिश कर रहा है, that will be disfavored. Let's see examples, then you will understand. तो अभी अभी हमने देखा 3, 4, 5, 6, 7 saturated. देखो ये वाला exotet है. 3 exotet is favored if I have this NH2 over here, and let's say if I have the bromine over here, तो ये भी cyclize करेगा. This is also favored. If I have one more carbon, that will be 5 exotet, 6 exotet, all of these are favored. Exotet sub favored है. Similarly, if I just increase the number of carbon over here, it will become 6 exotrig. मतलब जहाँ outside push हो रहा है, जो भी outside push हो रहा है, whether saturated, whether unsaturated, all are favored. लेकिन जो endo push हो रहा है, somebody who is being having a leaving group inside, endotet, specifically saturated, are not favored. Okay? देखते हैं इसका example. ये example देखो. What is happening? So you are having a base next to a sulfonic and you are having an active methylene proton next to a sulfone group. तो क्या होगा? Base के presence में negative charge आ गया. ठीक है. What is the usual reaction that you will see? What is the reaction that you will see? This negative is going to attack somewhere. What is the electrophile? The only electrophile is the methyl. अभी अगर methyl पे attack करेगा यहाँ से, so this O minus is going to go along with the sulfonate group. तो ये क्या हुआ? ये कोई cyclization reaction है? Is it a cyclization reaction? No, it is not a cyclization. It is not actually making a ring, but it is called 6 endotet. Okay, क्योंकि ये माइनस चार्ज है, ये मिथाइल के ऊपर अटैक करेगा. So इसका classification 6 endotet ही है, but it is going to be disfavored for the ring formation. So that is why the ring opens from the other side and it gives you something like this. Got the point? That these kind of reactions are disfavored to form a ring, so it would like open up from the other side. ये just एक example है guys. अब हम आगे चलते हैं थोड़ा सा. पूरी terminology याद नहीं रखनी है. We are just going to see a few examples, and if it is like burdening your mind a lot, तो कोई जरूरत नहीं है याद करने के लिए, जो एकदम बेसिक चीजें जो इम्पोर्टेंट है वही याद करेंगे एंड देन वी मूव ऑनवर्ड्स। ठीक है, चलो। आई थिंक दैट इट has बिकम टू मच टू रिमेम्बर। नाउ व्हाट हैपेंस इज, ये देखो, 3, 4, 5 एंडो ट्रिग आर डिसफेवर्ड, बिकॉज यू नो कोई भी रिएक्शन में एंडो आ गया, it becomes very difficult to make it favorable. Look at this reaction over here, nitrogen attacking over this carbon to, you know, if it is attacking over here तो इसका electron density अंदर जाएगा ना, it will not favor it because it is going inside. So 5 endo trig is mostly not favored, mostly not favored. ठीक है, rather what will happen, rather यहाँ पे जो ये एस्टर है उस पे ये डायरेक्टली अटैक करेगा and it is going to open the oxygen bond, ये ethoxy यहाँ से लीव कर जाएगा, it is going to better form this. Have you seen a question in your recent CSIR paper where, जिन्होंने recent paper solve किए हैं, मैंने करवाए हैं बहुत सारे, तो जिन्होंने solve किए हैं they will know what is the difference in the product when you are having these two groups. Yes, yes, you will say, ma'am, this is to doing direct addition. Very good, we understood it is doing 1,2 addition. But why is the sulfur doing the 1,4 addition? If if the 5 endo trig is disfavored all the time, then how can this attack over here and do a reaction like this, a cyclization in this way? Yes, you can ask me that question, no? 1,2 and 1,4, why the difference? Why is that so? The difference is because of the hard and soft acid base concept. Definitely, it is not because Baldwin's rule is wrong. Okay, Baldwin's rule अपनी जगह पे सही है, यहाँ पे जो difference आ रहा है इन दोनों में, that is because of the hard soft acid base concept. Okay, all right. Baldwin rule will always favor exotrig rather than endotrig. Endotrig not possible, exotrig is possible. ठीक है, तो कोई भी एंडो वाला रिएक्शन फेवर्ड नहीं होता है, भले ही वो ट्राइगोनल प्लानर हो या टेट्राहेड्रल हो, नॉट फेवर्ड. ओके, वेरी इजी कॉमन सेंस. आगे चलते हैं. व्हाट इज हैपनिंग, यू कैन से ऑल्दो कुछ एंडो वाले रिएक्शन फेवर्ड होते हैं. व्हाट आर दोज? 6 endo trig, this is going to be favored. Okay, so guys, we are not going to burden our minds with what is not favored. वो याद नहीं रखना है, कौन सा favored है वो याद रखना है. ठीक है, ये देखो, maximum exotrig reactions are favored. All the exotrig या exotet reactions are favored. Maximum, almost all are favored. लेकिन एंडो में कौन सा फेवर्ड है? 6 and 7 एंडो ट्रिग आर फेवर्ड. ओनली दिस वी आर गोइंग टू रिमेम्बर अलोंग विद दिस. ओके, 6 and 7 एंडो ट्रिग. गॉट इट? व्हाट टू रिमेम्बर, व्हाट नॉट टू रिमेम्बर. ठीक है, यस. सो वी मूव ऑनवर्ड्स एंड वी लुक एट दिस मॉलिक्यूल. व्हाट इज हैपनिंग? ये एक इनोलेट है और ये इनोलेट क्या कर रहा है? इट इज डूइंग अ माइकल एडिशन, isn't it? So guys, Michael addition is a endo reaction only because when this double bond is being attacked, तो ये electron density तो अंदर की तरफ जा रहा है ना. So all the Michael additions are endo reaction only, and that's why all the Michael addition are going to give you a 6-membered ring only. तो सारे Michael addition क्या हो गए फिर? All of those are endo trig, isn't it? A Michael addition is a endotrig reaction and that absolutely happens. तो ये तो favored हो गया है, right? So you will never have a enolate like this. कभी भी ऐसा enolate कभी नहीं होगा जो इधर अटैक करेगा just because Baldwin's rule has to be followed. No. So that's why remember this, 6 endotrig Michael addition is going to be favored. Everyone gets it? Very important, this one, very easy, very important. ठीक है, तो ये कुछ हमारे पास अच्छे वाली चीजें हो गई। अब कुछ एक्सेप्शंस भी देख लेते हैं गाइस। Exception to Baldwin's rule. There are few exceptions, obviously. This one I've already told you that sulfur is going to do the attack on the five-membered ring like this, and it is going to give you the endo trig. Nitrogen did not give you endo trig, sulfur gave it because of the hard soft interaction. वो एक अलग reason है, ठीक है? So this is an exception because of the HSAB theory. And one more exception over here. ये देखो कि ये जो एंडोट्रिक बना है रिएक्शन यहाँ पे, that you are having a carbonyl and the oxonium ion, you know, whenever you are forming the acetal, जब भी हम acetal बनाते हैं तो in the mechanism what happens, the intramolecular, let's say this was a diol, so it is going to the alcohol is going to attack over the oxonium ion. So this is again endo, क्योंकि ये डबल बॉन्ड है, ये अंदर की तरफ खुल रहा है तो ये एंडो बन गया। पर ये क्यों हो रहा है? Why the exception is there? Why this exception is there? Because a charge has to fall over oxygen. ऑक्सीजन पे पॉजिटिव चार्ज है तो ये अल्कोहल कभी भी ऑक्सीजन पे अटैक नहीं कर सकता। ऑक्सीजन does not have vacuum d orbital, so it has to attack over carbon only and open the ring like this. So this particular 5 endo trig is favored. Okay, so there are exceptions, but the exceptions are having strong reasons also कि इसको बेचारे को तो इलेक्ट्रॉन डेंसिटी चाहिए और ये HSAB से बाउंड है, so that's why the exceptions, but most of the reactions will follow the Baldwin's rule. Okay, ये देख लो. So maximum we are going to remember the trig and the tet only. We are not going to remember the dig क्योंकि बहुत कम आते हैं, एक या दो आते हैं, ज्यादा नहीं आता. So all the endo dig cyclizations are favored. Endo में कौन कौन फेवर्ड है? ऑल एंडो डिग. क्यों है? लेट्स सी दैट. ऑल ऑफ देम. एक्सो नहीं फेवर्ड है, एंडो फेवर्ड है. व्हाई? लुक ओवर हियर. यू आर हैविंग अ ये देखो, यू आर हैविंग अ ट्रिपल बॉन्ड ओवर हियर. Now, if I'm having a base, what is the base going to do? Remove a proton naturally. अब ये O minus क्या करेगा? This O minus is going to definitely do the attack on a carbon such that the electron density falls inside like this. ऐसे करके. Okay, तो ये तो endo हुआ ना? So this is how the reaction is going to end up always. Whenever there is an attack on the triple bond intramolecularly to form a cycle, it is always going to bring the negative charge inside the ring. So all the endo-dig reactions are going to be favored. Does it make sense? Dig means diagonal. Okay? or like linear. तो अब हम इसके जो चार्ट है, इसके चार्ट पे हम आते हैं, ये हम देखते हैं. एक बार पढ़ने से समझ नहीं आए तो दो तीन बार इसको रिवाइज कर लेना. इट इज वेरी सिंपल. So we were talking about trig and tet. We know that all exo reactions are going to be favored. लेकिन 6 and 7 endo are also favored. This is what we remember from our previous discussion. चलो, तो ये हम आते हैं tet के ऊपर. एंडो में तो कुछ भी फेवर्ड नहीं है. Nothing is favored. All are disfavored only. एक्सो के अंदर all are favored. Okay. ट्रिग के अंदर 3, 4, 5 is disfavored. 6 and 7 endo trig are favored. Okay, 6 and 7 endo trig are favored. See guys, as soon as you talk about these, अगर आपको ऐसा हो जाए कि आपने बात करी 6 endo trig के बारे में और फट से आपके दिमाग में ये एग्जाम्पल आ गया कि 6 endo trig का मतलब माइकल एडिशन, तो बहुत अच्छा होगा. Okay, it will be awesome if you are able to remember that what is the example of 6 endo trig. Michael addition, intramolecular Michael addition, Robinson allylation. तो वो वाला जो reaction है, that is 6 endo trig. This is the section of endo and this is exo. तो बहुत अच्छा होगा. You will know it is favored like this. और exo तो सारे ही favored होते हैं. Yes, very easy. अच्छा, आई ऑल्सो टोल्ड यू ऑल द एंडो डिग आर फेवर्ड, क्योंकि जब भी ट्रिपल बॉन्ड प्रेजेंट होता है इलेक्ट्रॉन डेंसिटी ऑलवेज कम्स इनसाइड द रिंग. सो 3 4 5 6 7 ऑल द एंडो डिग आर फेवर्ड. लेकिन एक्सो में 7 6 और 5 लाइक बड़े वाले रिंग फेवर करते हैं. बट यूजुअली व्हाट हैपेंस, वी डोंट सी मच ऑफ दीज रिएक्शन. ये ज्यादा नहीं देखे जाते, सो वी डोंट डिस्कस देम much. All right, we discuss for the diagonal, we discuss the endo reactions mostly. Got it? तो अब ये जो टेबल है ये इतना मुश्किल नहीं है. This has become very easy. Yes or no? Yes. This table must have become very easy for all of you. अब हम आगे चलते हैं and we do one more aspect of the stereo electronics, that is the NMR aspect, guys. This is very important. Directly questions are being asked और आजकल तो स्पेक्ट्रा के फॉर्म में भी क्वेश्चन आने लगे हैं. So let's see them one by one. Look at this. Everyone knows about topicity. Yes. Let's say I've drawn a molecule like this. तो इसमें ये दोनों प्रोटॉन्स का क्या रिलेशन है, इन दोनों का क्या रिलेशन है, and so on and so forth. You know topicity, right? So there are different groups. Based on that they are going to give you different NMR value. तो वो भी स्टीरियो इलेक्ट्रॉनिक का ही पार्ट हो गया ना. Because of stereo you are getting a difference in the characteristics of the groups, right? Enantiotopic, diastereotopic, homotopic groups. So enantiotopic groups can be distinguished by system that can tell right from left only. मतलब कि वो magnetically equivalent होते हैं. Magnetically equivalent मतलब they'll give you the same NMR value, isn't it? They will appear identical in the proton NMR. Also, homotopic groups are chemically as well as magnetically identical. ये तो chemically भी identical है और magnetically भी identical है. Magnetically equivalent. Magnetically equivalent मतलब they are going to be giving you the same NMR value. Only the diastereotopic protons, they are going to give you a different chemical shift value in the NMR spectrum. This you already know. तो हम आगे चलते हैं. We see examples. We see examples. Look at this molecule over here. इसका नाम ही है frontalin. ठीक है. Look at this molecule. A very very nice example. ये देखो, a very nice example of two different protons on the same carbon. Same carbon पे दो proton है. What is the relationship between them? You tell me guys quickly. Quickly tell me what is the relationship between these two protons. Yes. See, I don't, whenever I see a C2 axis which can exchange the two protons, वो हो जाते हैं homotopic. When there is a sigma plane of symmetry which can basically reflect the two protons, those are going to be enantiotopic and these are going to give the same delta value. लेकिन जब वो diastereotopic हो जाते हैं, कोई relationship नहीं है, no relationship, C2 axis भी नहीं है, sigma plane भी नहीं है. So these two are basically exactly, these are diastereotopic in nature. तो diastereotopic है, which means they'll give you two different signals and they are, even though they are geminal, ये दोनों प्रोटॉन क्या है, ये तो geminal प्रोटॉन है ना on the same carbon, so yeah, they are different and that's why they are going to give you geminal coupling. All right, geminal coupling मतलब ये एक हाइड्रोजन है, ये इसको स्प्लिट करेगा और ये भी इसको स्प्लिट करेगा. Both of them are going to appear as doublets. Okay, so this, both of these are appearing as doublets. These are diastereotopic protons and this has arisen because of the difference in stereochemistry, isn't it? आगे चलते हैं, एग्जाम्पल नंबर 2. Talk about these two hydrogens over here. Yes, the two hydrogens on this carbon as well as the two hydrogens on this carbon. What is this? N-benzyl glycine molecule. बहुत simple है ये तो. Hello Shankar, yes, welcome. Yes, very easy. You see that there is a sigma plane which is cutting through the molecule. मतलब वो sigma plane कहाँ है? वो sigma plane इस तरीके से है such that this hydrogen which is above and the one which is below, they are reflected through this sigma plane of symmetry. So what are these two? These two are enantiotopic. And the same for this enantiotopic. तो जो enantiotopic होते हैं, they are going to give you the same value. Only one peak. So this is one peak for two hydrogens, and the same over here, one peak for two hydrogens. Like this. This is less de-shielded. All right. Very beautiful concept. Third one. Third example. ये देखो third example. मैंने क्या किया? इस मॉलिक्यूल में से एक हाइड्रोजन को हटा के एक मीथाइल लगा दिया. जस्ट दैट इज द चेंज. That is a simple change. Now what is the relationship between these two hydrogens now? Beautiful example. Yes. So guys, अगर मैंने यहाँ एक मिथाइल लगा दिया, then the sigma plane which was actually reflecting these two hydrogens does not exist anymore, because ये मिथाइल है above और ये hydrogen है below, so there is no more the sigma plane present, which makes these two hydrogens as diastereotopic. Exactly. Very good all of you. ये दो हाइड्रोजन अब diastereotopic हो चुके हैं क्योंकि वो जो sigma plane था वो नहीं है. That's why they are both going to split each other into doublets. ये भी doublet है, ये भी doublet है, with almost the same, with exactly the same height. So ये देखो green and brown, these are two different protons splitting into doublets. All right, and the pink one over here is going to be again a quartet because ये methyl के पास में है. So it is like this. Got it? And the methyl is split into a doublet because of this hydrogen, one single hydrogen. So this is how the stereochemistry affects the spectrum. और ये अगर आपको स्पेक्ट्रम से डिड्यूस करना है तो बहुत इजीली आप मॉलिक्यूल का जो स्ट्रक्चर है वो डिड्यूस कर सकते हो. एक बहुत इंपॉर्टेंट चीज है गाइस विच वी कॉल एज द कपलिंग कांस्टेंट. बिफोर जस्ट साइनिंग ऑफ, आई जस्ट वांट टू टेल यू अबाउट दिस. Please be careful about coupling constant in your examination. देखो हम क्या पढ़ने आए थे, हम क्या पढ़ रहे हैं, हम NMR पढ़ रहे हैं. But the NMR that we are studying is a direct, it's a consequence of stereochemistry only. Okay, so variation of J with the ring size of some simple cyclic alkenes. So everyone knows about the Karplus equation, Karplus curve. Yes or no? Do you all know about the Karplus curve? That is, when the dihedral angle changes, the coupling also changes. Yes or no? Let's say मेरे पास दो ऑर्बिटल है इस तरीके से. Let's say I'm having a 0-degree angle or a 180-degree angle. तो according to the Karplus curve, तो ये जो 0 डिग्री होता है which is syn periplanar and the 180 degree which is anti periplanar, in these two conditions the J value is going to be maximum. Yes or no? Yes, everyone knows this कि जो भी trans एकदम से syn मतलब एकदम parallel like this और anti एकदम से anti periplanar like this, that is going to have the maximum coupling constant value. Yes, and everyone which is in between तो उसकी वैल्यू बहुत कम आएगी. और स्पेशली अगर जो हमारा एंगल है, if the angle is around 90 degree orthogonal, the J value is going to be minimum. Yes, then the coupling constant value is going to be minimum. अब ये सारा हम इन examples के ऊपर देखते हैं, ठीक है? So you already know about these alkenes. इन alkene के बारे में आपको पहले से पता है that because they have been asked many times in the examination that when you are having a trans alkene, so this is exactly anti-periplanar, exactly 180 degree. That's why the coupling constant is much high as compared to this. तो guys ये एकदम से जीरो तो नहीं है ना, this is 11 hertz because the cis this is not exactly zero because it is like जो एक plane के ऊपर है समझ गए, but it is like moving away from each other. So if these orbitals have to interact, they cannot interact like this. लेकिन अगर इन ऑर्बिटल को इंटरैक्ट करना पड़ा तो ये बहुत आराम से इंटरैक्ट करेंगे. गॉट द पॉइंट? यस और नो? Why the cis alkene is having a lower coupling constant and the trans is having a higher coupling constant. Okay? Yes, but don't always say that the trans is always going to have a higher coupling constant. क्यों? क्योंकि हमें एंगल देखना है. ये देखो, look over here. The cis chrysanthemic acid and the trans chrysanthemic acid, the difference in the structure over here is going to help you understand. ये जो cis acid है, the hydrogens are like this. They are on the saturated carbon now. The J value is 8 hertz, coupling constant is 8 hertz. लेकिन अगर यही trans हो जाते हैं तो ये J value 5 hertz आएगी. So here the trans is having a lesser value. Why? Why? Because the angle is not 180 degree like this one. It is saturated. No. This is a saturated example. इसका trans का तो और भी बुरा हाल है. They are not at all anti-periplanar. But they are still, the cis at least, they are at least thin periplanar even though they are like going in different directions. But फिर भी जो dihedral angle है वो zero है. Got it? So here when we are talking about saturated carbons, then the cis is going to have a greater coupling constant than trans. ये example समझ में आ गया है? Yes, everyone gets it? Third example over here, this one. Again the epoxide, the trans is having a coupling constant 2 hertz and the cis is having a coupling constant 5 hertz. Okay, beautiful examples guys. ये example आपको book में ही मिलने वाले हैं, ये आपको ढूंढने से भी नहीं मिलेंगे कहीं और. Okay, now let's look at this variation, this particular variation. What are we talking about? We are saying कि ये जो दोनों हाइड्रोजन है, see both of this hydrogen over here, they are present on the same plane. All are planar. जो रिंग का प्लेन है उसी प्लेन पे दोनों हाइड्रोजन प्रेजेंट है. So basically they are not having any angle, torsional angle, but still the hydrogen, the angle between these hydrogens are because of the ring size. जैसे रिंग साइज छोटा होगा एंगल इंक्रीज हो जाएगा. द रिंग साइज इंक्रीजेस, एंगल डिक्रीजेस, isn't it? The angle goes on decreasing because of the ring size. And look over here. If you consider these orbitals, these are having the worst interaction and these are having somewhat better interaction क्योंकि ये जो parallel वाली condition होती है, parallel condition is the best condition for the coupling to take place. ठीक है, यहाँ तो ये बिल्कुल parallel नहीं है. So what happens is as the angle increases between the hydrogens, the coupling constant decreases, and here the angle is minimum, the coupling constant is maximum. Okay, so for alkenes, जो alkenes होते हैं, alkene के लिए ये बहुत important है how you see the coupling constant. With the bond angle it is going to decrease. चलो, now I have some points to which I have jotted down over here. You can directly study from here. The size of the 2J and the 3J coupling constant. 2J मतलब कि geminal. This is 2J. 3J is this. ठीक है, कैसे होगा? The dihedral angle influences the coupling constant. जो 3 bond coupling होती है, that is maximum at 180 degree and 0 degree, and that is 0 minimum at 90 degree. This we have also seen from the Karplus equation. तो Karplus equation is mostly for the 3J coupling only. ठीक है, आगे चलते हैं. The ring size which leads to spreading out of bonds and lower the 2J and lower the 3J coupling in small rings. तो जो smaller ring होती है, जैसे कि 3-membered ring over here, the coupling becomes least because of the spreading out of these hydrogens. Okay. Electronegative atom which decrease the 2J and 3J coupling constant between protons. तो जो electronegative atom होते हैं, they also decrease the coupling between protons because they tend to pull away the electron density from the hydrogens. इसीलिए pi system which increase the 2J coupling constant between protons. All right. So जो pi system होता है जब भी between two hydrogens, see look over here, if I'm just comparing two hydrogens like this and two hydrogen like this, so definitely अगर pi system आ जाएगा बीच में, so what will happen, the bond becomes shorter. The bond becomes shorter as compared to this one, and that's why they will come close, and that's why it's going to be increase in the coupling. So that is how it is going to be. ठीक है, ये कुछ important points है regarding the coupling constant which you can remember. Now we go to questions. We are going to solve 3 questions only, and these are like really nice questions. देखो first one. Predict the most favorable conformation for these insect pheromones. So basically ये जो spirochetal हमने बनाया था starting में, ये insect pheromones है, लेकिन इसमें ये question में ऐसा पूछा है कि आपको सबसे ज़्यादा favored conformation बनाना है. So according to you, which should be the most favored? There is axial, equatorial, one conformer. There is equatorial, another conformer. There is axial, another conformer. ये 3 conformer रहते हैं usually of the spiro, and we know that the axial one is the most stable. Yes or no? Yes, the axial one, this becomes the most stable one. क्यों ऐसा? आपको पता ही है, double anomeric effect is working. So for these two, there are actually 3 axial isomers are possible, which are going to be 2 diastereomers and the DL pair, of course. All right, so that is how each of them are giving 3 most stable isomer. ठीक है, अगर आप बुक में पढ़ोगे, ये सॉल्यूशन मैनुअल से मैंने क्वेश्चन लिया है, क्लेडन सॉल्यूशन मैनुअल से. So you see that these compound can exist as 2 diastereomers and each diastereomer as 2 enantiomer. That's why they are going to be 3 different axial most stable conformers. Okay, yes, let's move onwards. Problem number 4 I found really interesting. ये देखो, explain why this cyclization gives a preponderance 3:1 of the oxetane, though tetrahydrofuran is much more stable. ये ज़्यादा stable होना चाहिए, पर ये क्यों बन गया? ये question है. Okay, just try this out and tell me which cyclization is taking place. नाम बताओ, according to Baldwin's rule, क्या नाम होना चाहिए oxetane बनने के लिए? Yes, write in the comment sections. let's say I have formed this kind of a iodonium ion. ठीक है, तो अब selectivity आएगी that I can attack over here, I can attack over here. If I attack over here, it's going to be forming a four-membered ring, and the iodonium ion opens outside, so it's 4-exotet. Okay. नो 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 नो, नॉट ट्रिग. एक्सो ट्रिग नहीं बनेगा, टेट हुआ ना, क्योंकि ये तो आयोडोनियम है. सो दिस पॉसिबिलिटी, दिस अटैक ओवर हियर इज 4-exotet on the saturated carbon, right? And this one over here, this one, red one, अगर ये ऐसे अटैक करेगा तो ये क्या बनेगा? Inside it is opening, it is 5-endotet. So according to the Baldwin's rule, what have we studied? कि जो tetrahedral के ऊपर, see, you remember that table? Let's go to that table. ये रहा tet वाला जो था, इसमें 5-endotet was disfavored and 4-exotet was favored. तो बस चलो आगे. कहाँ गया? ये रहा. So this is 5-endotet disfavored, 4-exotet favored. That's why the four-membered ring forms. Got it? Got it? Very nice. तो ये दोनों आपको पूरा solution manual में अच्छे से दिखाया है. You are forming the iodonium ion like this. You are doing this process. This is going to go through the 4-exotet reaction, और ये नहीं होगा because ये जा रहा है 5-endotet से. Endo है, within the ring itself it is going to open up. ठीक है. Also, what about the stereochemistry? It is very simple, that if the iodonium forms above, the OH is going to attack from below and it's going to become trans. ठीक है, तो दोनों ग्रुप आएंगे, वो ट्रांस आएंगे. आप यहाँ पे अच्छे से देख सकते हो उसको. ठीक है, आगे चलते हैं गाइस. Look at this question, very important. The two diastereomers of this cyclic ketolactam have been prepared. The NMR spectra have many overlapping signals, but the marked proton, this one, can be seen clearly. In isomer A, it is at 4.1 to 1 hydrogen. J value coupling constant is 3.5, and in isomer B, it is 3.30, 1 hydrogen, doublet, triplet, J value 4 and 11. तो अब A और B क्या है? ठीक है, मतलब cis और trans based on this hydrogen. इसका भी नहीं पता है whether they are cis or trans. So what are you supposed to do? You are supposed to draw the D gallon system. Yes, we are supposed to draw it. ड्रॉ करने के बाद में इंटरैक्शन देखो, that who is going to interact with whom to give you the coupling constant. ठीक है, cis trans A B, कौन सा कौन है, which is which? All right, let me just make it easy for you. तो देखो मैंने ड्रॉ कर दिया है. फॉर एग्जाम्पल, let's suppose I'm having the trans isomer over here where the two hydrogens are Navneet, you don't have a plane of symmetry usually. Okay, पर अभी हम उसके बारे में बात नहीं कर रहे. We are just looking at the protons. We will, if there is any question that comes like this, we will definitely discuss. ये देखो, or if you have a diagram, you can send me on Telegram. ठीक है, that will be better. So here we see the trans, here we see the cis system. All right. Now the trans is going to be drawn like this. Both of these are trans. Trans में coupling बहुत अच्छा होता है, you know that already. J value is going to be high. और ये दोनों cis है, तो cis में it is not going to be a good coupling. The J value must be low. Got it? So here I see that there are these two trans hydrogen. तो ये दोनों ट्रांस हाइड्रोजन है, ये कपलिंग कर रहे हैं 10 की, मतलब हायर वैल्यू, तो 11 10 दैट इज अ हायर वैल्यू. ऑल्सो यहाँ पे एक और हाइड्रोजन है विच इज लाइक दिस. सो this hydrogen over here, this is also axial. So two axial coupling will give you 10 value, and one equatorial and axial coupling is going to give you the 4 hertz value. तो ये जो B isomer था, the one which is having two coupling constant value, this is the trans isomer. Got it? Because you are getting two couplings. Okay. However, the cis isomer is doing what kind of coupling? देखो यहाँ पे axial आ गया है, but यहाँ तो equatorial है ना. So if this one is about to do the interaction with these two hydrogen, that will also be axial equatorial. So all of the interaction, first interaction with these two, then these two, and then these two, all of these are equatorial axial interaction. तो सबकी value 3.5 के आसपास ही रहेगी. So the cis isomer is the one with A. A is cis and B is trans. Okay? Yes. All right. Now last question. ये देखो, question number 12. I am giving this to you as a homework because you are going to try to solve this. ये आपका homework है, आपको करना है. इसका solution भी दिया है in the Claydon solution manual. Just take a screenshot and try to do this by yourself. Okay? The answer is absolutely very, very easy. It's a very nice question, just like the previous ones. Okay? So yes guys, I hope that you liked this session. और फिर मिलेंगे हम, जल्दी मिलेंगे. और अभी गेट का एग्जाम खत्म हो चुका है, सारी प्रैक्टिस हो चुकी है, वापस से हम स्टार्ट करते हैं बेसिक से. ठीक है? So I'll see you all soon in another session of Claydon series. The next chapter is going to be chapter number 32, which is an even awesome chapter. ठीक है? So I'll see you all guys. Bye everyone, take care of yourself and join up the repeaters batch or the catalyst batch or the target batch, whichever you want to join. I'll see you all soon guys. Have a nice evening. Bye guys.